Now, when y equals to sine inverse of x, show that divide x equals 1 on square root of 1 minus x squared. Okay, so we have y equals to sine inverse of x. Now we have to show that divide x is equals to 1 on square root of 1 minus x squared. Okay, now let's not forget that when you have sine theta equals to k, theta is the same as sine inverse of k. So it means k equals that. It means y is not the same as 1 over sine x. Let's understand that. Okay. Now, before that, let's write this one as x equals to sine y, because y is the same as sine inverse of x. All right, let's take the derivative here. So this time it will be differentiating x with respect to y. So that will be the x dy. So sine is cos, so that will be cos y. So if that's the case, my divide x will be, so I've changed this one, that will be 1 on cos y. All right, now we are to show that this one equals that. So let's build on this. Now let's record this identity. Cos squared y plus sine squared y equals to 1. So we can find cos y here. So that will be cos squared y equals 1 minus sine squared y. So my cos y will be square root, so plus or minus that, 1 minus sine squared y. So in place of cos y, I'll put square root of, so let's go divide x 1 on, so we have cos y here as square root of that, square root of 1 minus sine squared y. Okay, and what is sine y? Sine y is x, so we can do that. From here we can write this one as 1 on 1 minus sine y, or squared is the same as this. So divide x be 1 on square root of 1 minus, so sine y is x here. So we have x squared. As simple as that. All right. So we have this. All right. So thanks for watching.